Hi, Mr. Corsie here. Now I'll be going over the solutions to the 2023 paper in some detail, so this will be a fairly long video. To help you find the particular question you're interested in, I've created headings for each question. If you slide along the timeline below the video, you should see these headings and hence locate the particular solution you want to look at. So let's begin the solutions. So here's question 1. We're told that a caravan was bought for £20,000 and it depreciated. That means it's lost value. 11% of that value has been lost in the first year, and then it continues to depreciate, to lose value, 6% for each of the next 2 years, and we have to calculate the value of the caravan 3 years after it was bought. So we've got £20,000 initially, and then during the course of that first year it's depreciated 11%, so it's lost 11% of its value. However, it must have retained 89% of its value. If it loses 11%, then it's retained 89%. That 89% and 11% comes to 100%. That's the whole value. Now, to find 89% of a quantity, you multiply it by 0.89. After all, 89% is 89 hundredths. 89 hundredths is 0.89. So multiplying this by 0.89 will give you a value which is 11% less than it started. So whatever that is, we now look at the second year's depreciation, and it tells us it's lost a further 6%. Now that's 6% of whatever this is, and therefore it's retained 94% of this value. And to find that, you'd multiply this value by 0.94. And whatever you get there, again, the third year, it's lost another 6% of this value, and it's retaining 94% of this value. And to find that, you take this value and multiply it by 0.94 to find the final value after 3 years. So the calculation we're going to have to do is to take £20,000, multiply it by 0.89. That then gives us this value, which we then multiply by 0.94 to give us this value, which we multiply by 0.94 to give us the final value of the caravan. So that's the calculation we have to do. And being in paper 2, we bring out our calculator and see what goes on. So £20,000 times 0.89 times 0.94 times 0.94, and that gives us that value. It's 15728.08 pounds. So the question says find the value after 3 years. So after 3 years, its value is £15,728. We'll say that's to the nearest pound. We can not at this stage be bothering about 8 pence in that value. But we have to, if we're chopping this off and approximating it, we'd have to say what we've done to it. So that's to the nearest pound. So £15,728. So question 2. We're given the information about the mass of one helium atom at 6.64 times 10 to the negative 24 grams. Now that's written in scientific notation or standard form. We're also told a flask contains 300 grams of helium, and we're asked to calculate the number of helium atoms in this flask, giving our answer in scientific notation correct to 3 significant figures. Well, let's take a different example. Suppose we've got a ball that weighs 2 grams, and we've got a bag that contains these balls, and we're told it's 6 grams in weight. And we say, well, how many of these balls, 2 grams, are contained in this bag? Well, the answer would be 3. And how do we know that? Because 6 divided by 2 is equal to 3. So total weight 6, individual weight 2. How many of these are there in this? 6 divided by 2 gives us 3. So how many of these are in 300 grams? We take 300 grams and divide it by the weight of one, the mass of one atom. So that's the calculation that'll give us the number of atoms in the 300 grams of helium. So let's enter this into our calculator. Now, 300 grams divided by, and here's the problem. This is in scientific notation. How do we enter scientific notation? We're okay with the 6.64, but what about this times 10 to the negative 24? Well, on my calculator there's a special button. It's got an EE on it, which I press, and then I put in negative 24. There's a negative, not the minus, the negative 24. And that's how I enter it on my calculator. There are other buttons, obviously. Look at this calculator. On this one, the equivalent of my EE button is an X button. So this means times 10 to the power of. My button means times 10 to the power of. So that's one example of a calculator. There are others. There it is. It says times 10 to the power X. That's the same button on this type of calculator. Look at this one. Sometimes hard to find where they are. There it is there. It's the same as my calculator. It says EE. And what about this one? Well, that's very hard to find. You'll notice it's there. And you'll notice it's above the main key, which means we have to use a second function button. So if we press second function, then press this, that's equivalent to pressing an EE button. So you need to watch your own calculator and decide what or how you fill in a standard form number. So I've entered mine, 300 divided by 6.64 times 10 to the power negative 24. And that gives me this answer. So I'll put that part of it, and then the E, remember, means times 10 to the power, and in this case it's positive 25. Now that's a huge number. It's a 1 with 25 zeros after it multiplied by this. It's an enormous number, and that's what you'd expect. Atoms are very, very small, and 300 grams of helium will contain an enormous number of atoms, approximately this number. Now we're asked to write it in scientific notation, that's what this is, but correct to 3 significant figures. So we'll need to approximate this. 1, 2, 3, we chop an 8 off, that one becomes a 2. So it's 4.52, and it's approximately times 10 to the power 25. And that's written to 3 significant figures. So there we are, an enormous number of atoms in 300 grams of helium. So here's question 3, where we're given part of a football pitch diagram, part of a football pitch. And here's the penalty spot, C, and there's a arc of a circle, and the circle has centre C. We're told its radius is 9.15 metres, and that the angle at the centre of that circle is 106 degrees, the one that goes with this arc AB. Now, if you imagine this arc getting larger and larger till it becomes the whole circle, the angle at the centre would become larger and larger until it eventually was 360 degrees. And that would mean that this arc has been extended to become the whole of the circumference. So at 360 degrees at the centre goes with the complete circumference of the circle, whereas this 106 degrees goes with that arc AB, which is the one we are trying to find. Now, that we can use as the basis of calculating the length of this arc, because 360 degrees going with the circumference, we know how to calculate the circumference. It's pi times the diameter. Now, the radius we know is 9.15, so the diameter will be twice that, which is 18.3. So pi times the diameter, 18.3. That's twice 9.15. So 360 degrees goes with whatever this length is. So let's try and work out what tiny wee length would go with a 1 degree angle at the centre. Now, since 360 degrees goes with this number, 1 degree would go with 1/360th of that number. So basically dividing that number by 360. But that's not what we're after. We're after the length that goes with 106 degrees. So if we know that 1 degree goes with whatever this number is, 106 degrees would go with 106 times this number. So we take whatever this number is, we're building up a calculation here, whatever this number is times 106. And that's basically the calculation that we do. On the top of that fraction, we've got a 1 times pi times 18.3 times 106. And on the bottom of that fraction, we've got 360. So that's the calculation that we're going to do now. We take a pi and use the pi button for this, it's easiest. So pi times 18.3 times 106, and then we divide by 360, and that equals, and there's our answer, 16.927, and so on. Now, what does the question ask us concerning accuracy? Calculate the length of arc AB. Doesn't have anything about accuracy, so we'll need to approximate this, and usually it's 3 significant figures, so 1, 6, 9, chopping a 2 off, the 9 stays as it is. So we'll say it's 16.9, measurements are in metres, and that's to 3 significant figures. When you approximate answers, always say how accurate your approximation is. So that arc AB, the length is approximately equal to 16.9 metres, the three significant figures. So this is question 4. Here we have a triangle JKL with various lengths of sides and one of the angles given to us. We're asked to calculate the size of angle JKL. Now it's obviously not a right angled triangle, so Pythagoras' theorem's out the window. So that leaves us with either the sine rule or the cosine rule. Now if we look at what we know, we see we have an angle and the length of an opposite side. We're asked for this angle. We know the length of the opposite side. So that would indicate the sine rule. And if we look at your formula sheet, which you'll get during the exam, the sine rule, A over sine A equals B over sine B equals C over sine C. So we're dealing with a JKL triangle, not an ABC triangle. So let's draw a triangle ABC. Now, little a is the side opposite angle A, little b is the side opposite angle B, and little c is the side opposite angle C. So the pattern is side divided by the sine of the opposite angle, a side divided by the sine of an opposite angle, a side divided by the sine of the opposite angle. So in this case, we would use a side, that's little j, divided by sine j, equals a side, that's little k, divided by the sine of the angle opposite, that's k. So that's what we're going to use. Let's plug in values as a first stage. So the side length 7, that's little j, divided by the sine of 25 degrees. Well, that equals little k, that's 10, we know that, divided by the sine of the angle opposite. That's what we're trying to find. We're trying to find the size of angle k, or JKL. So let's do some manoeuvring here. Let's get rid of this divide by sine k by multiplying both sides by sine k. So this multiplied by sine k, the sine k will appear on the top of the fraction, divided by sine 25 equals, and we've got rid of that divide by sine k. Now again, let's get rid of this divide by sine 25. Let's multiply both sides by sine 25. So that gets rid of that. This leaves us 7 sine k equals 10 times sine 25, multiplying the right hand side by that. One final move to get sine k on its own, we get rid of this multiplying by 7 by doing the opposite. We divide both sides of this equation by 7. So that gets rid of 7 on that side. And if we divide this side by 7, it's at the bottom of a fraction. And that therefore gives us the calculation that we've to do to find sine of k. So let's grab our calculator and see how we can get on with this calculation. So we've got 10 times sine 25. There's sine. Now, hang on. Is my calculator in degree mode? Well, yes, it is. Sometimes your calculator might show a GRD or an RAD. Make sure it's showing a DEG, otherwise your answers will be wrong. So it's sine 25 degrees, and we have to divide by 7. So that gives us 0.603 3, 7, and so on. Now that's the sine of angle K. So in effect we want to undo this sine just to leave K. So the opposite of the sine on the calculator, mine it's a sine, and yours it's probably sine to the -1, sine with a little -1, which you'll probably find just above the sine button. So using that on the 0.6037 etc, sine to the -1, which is the more common one, with that answer, which gives us an answer of 37.13 something, so 37.138 and so on. So that means K, the angle K, is 37.138 and so on, that number of degrees. Now, does it ask us for an accuracy? No, it doesn't. So we'd probably say that angle JKL, which was how they named it, is approximately equal to 37.1 degrees. And we'll say what we've done to that. That's to 3 significant figures. So 37.1. So here we have question 5. Left hand side of this logo we've got what looks like a rugby goal post, 2 right angles there, and on the right hand side we've got a regular decagon, lots of lines of symmetry in there. And we're asked to find the size of this shaded angle. So let's concentrate on this point that has several angles around about it. And let's have a closer look at that. Here we are. So, how do we do this? Well, if we found all the sizes of these angles, and remembering that the angles around about a point add up to 360 degrees, then we'd be well on our way. So at least we know this one is 90 degrees. Now to find the size of this or this, we notice that all these angles are equal round about there. In fact, we've got this lovely isosceles triangle with this angle being the same as this, being the same as this, all the way around. There's 10 angles around this point, all equal, making up 360 degrees. So certainly a tenth of 360 degrees would be 36 degrees. And in an isosceles triangle, remember, these 2 angles are equal, and the 3 angles add up to 180. This part's 36, so it would be 144 for each of these. Half of 140 is 72. Easy check that on your calculator. So each of these angles 72. This one also will be 72. They're all equal, all these angles around the edge of this decagon. So I think we're virtually there, because to find the shaded angle, we take this 360 and take away the 90 and the 72 and the 72, and we'll see what's left. So let's just tackle that. Shaded angle would be 360 degrees minus, take away the 90, take away the 72, and take away the 72. So let's see what that comes to. If you don't trust your mental arithmetic, then use your calculator. And that's 72, and let's take another 72 away. What does that leave us? 126 degrees left for the shaded angle. So here's question 6. Nadim bought a flat, And over the course of a year, it increased in value by 8%, and now it's worth £94,500. We have to work out how much Nadim paid for the flat. So I'm going to show you two methods of doing this. So method one. And we don't know how much it cost him for the flat, but over the course of that year it increased by 8%. The value of the flat went up. So instead of being what it was worth, 100%, 8% has been added. So it's now worth 108% of what it was worth the previous year. Now, to find 108% of something, you multiply by 1, that's the 100%, 0.08, that's the 8%. So it's a factor times 1.08. The result, as we know, we're told, £94,500. So we have to go from this final value back a year to what we'll have to go against the arrow to find out what it was worth a year ago. So instead of multiplying by 1.08, I suppose the opposite, going against the arrow, would be dividing by 1.08. We can see that if we call the value of the flat originally x, how would we find 94,500? Well, we'd multiply x by 1.08, and that'll give us the 94,500. So a simple equation, let's divide both sides by 1.08. And that's what we were saying when we looked at that diagram and decided we were going this way against the arrow. We'll do the opposite of multiplying by 1.08. We'll divide by 1.08. So we can work that out. Grab our calculator and do that calculation. So it's 94,500 divided by 1.08. And that gives us 87,500. So that's what the flat is worth after, originally it was worth 87,500. So the original value was that. So that's one method of doing it. And let's look at method 2. And in this method we say, well, okay, we've got a flat that's now worth 94,500, and that's after 8% was added. So 108% of the value is now 94,500. So what would 1% be? If 108% is that, 1% would be 108th of that. We divide by 108. So 1% would be worth whatever that comes to. But it's not 1% we're after. The original value is 100%. It's been increased to 108%. It used to be 100%. That was the whole value originally. So if we've got 1% being worth this, then 100% will be worth 100 times that. So we take whatever this number is and multiply it, in other words that appears on the top, by 100. So that's the calculation we can do now. Let's hope it works out exactly the same as before, or I think I'll give up my job of teaching mathematics. Let's check that. Well, thank goodness for that. I'm still in a job. So that's 87,500. And that's the original value. Okay. case you're in doubt about what that sum of money means. So here we're given a formula and we're asked to change the subject of this formula to M. At present, the subject is P. If we wanted to find the value of P, then we would use this formula and plug in values of M and N and R and do all these calculations with M and N and R. Would end up finding P. So the subject of this formula is P. So we want the subject to be M, therefore we want M on its own on one side of the equation. So we have to get rid of all the rubbish that's round about M. So let's first concentrate on this divide by 3, this third. And we would get rid of this divide by 3 by doing the opposite, multiplying by 3. Both sides should be multiplied by 3. So 3 times P would be equal to... Now, be careful about this because it's not just that first term here. There's 2 terms. There's a third MN and there's minus R. Both of these terms have to be multiplied by 3. That's why I'm putting that intermediate step in. So 3 times a third's 1. 1 times MN is just MN. That's why we multiplied both sides by 3 to get rid of that third, and it's gone. However, we need to be sure that we multiply this term here by 3. 3 times negative R is negative 3R. We're subtracting 3R. So in our attempts to get rid of everything round about M, we've still got all this to get rid of. Now, minus 3R, we can do the opposite. We can add 3R to both sides. Keeps it balanced. So on the left hand side we'll have 3P plus 3R, and of course this has disappeared now, these cancel, and we're left with MN. Well, we're getting very close. M on its own, we need to get rid of a multiplying by N. We'd have to divide both sides by N. So we take the whole of the left hand side and divide it by N, and Mn divided by N, we cancel N, top and bottom of the fraction. We're just left with M, which is why we divided both sides by N. Now normally formulae don't look this way. The subject of the formula is usually on the other side. So we just swap the 2 sides round. So we would get the value of M by taking 3 times P, adding 3 times R, and dividing that by N. I suppose if you want, you could take out a common factor of 3 up at the top and write it like that. That's a perfectly valid form of the answer. So here's question 8, and we've got a wooden beam used to support a wall. It's built in horizontal ground as shown in this diagram, and we've got all the measurements there, and we've to determine whether the wall is perpendicular to the ground, justifying our answer. So let's just remind ourselves, if we have a situation like this where we do have a right angle, then Pythagoras' theorem tells us that a squared plus b squared equals c squared. Now another way of saying this, the other way round, would be to say that if a squared plus b squared does not equal c squared, then we can definitely say that this was not right angled. The triangle we started out with is not right angled. So we're basically starting out with a triangle whose sides are A, B and C, and we determine that a squared plus b squared is different from c squared. That would mean it's not right angled. So that's the strategy we'll use here. So we'll check AC squared plus BC squared. That's the 7 squared plus the 4 squared. And that's 49 plus 16. So that's 65. And we'll check that against what would have been the hypotenuse if this is right angled. We might still find out it's right angled. So AB squared, that's 8 squared, and that's 64. Well, now it becomes clear that AC squared plus BC squared does not equal AB squared. So this is not a right angled triangle. Now, have we answered the question? All we've discovered is this is not a right angled question, a right angled triangle. And the question says determine whether the wall is perpendicular. So the wall cannot be perpendicular. The only way the wall would be perpendicular with the ground is if this was a right angle. We've just shown it's not. So the wall is not perpendicular to the ground. So here we have question 9, and we've got a concrete block, that's it shaded. It's in the shape of a large pyramid. You can see the outline of the large pyramid, and they've removed a small pyramid from the top of that, and all the dimensions are given to you. And we're asked to calculate the volume of this shaded block that's left. Now, in your formula sheet, you have the volume of a pyramid is given by a third the area of the base times the height. That's given to you in the exam. So the strategy here, volume of the block it would be the large pyramid minus the bit that's missing, the small pyramid, the volumes of these. So that's our strategy. We find the area of the volume of the large pyramid and take away the volume of the small pyramid. So let's start with the large pyramid. Its volume will be a third the area of the base. Now we're told, in amongst all this, that this area of the base of the large pyramid has area 90 centimetres. Well, it's got a square base of length 90 centimetres, so its area would be 90 times 90. So that's 90 squared. That's the area of the base of the large pyramid. Third, area of base times height. Now the height we can see goes from this right up to the top. So that's a 60 plus a 48. That's 108 centimetres in total. So that would be the height of that large pyramid. And let's take away the volume of the small pyramid. Again, it's a third. Now, the area of the base of the small pyramid, we're told that the small pyramid has a square base of length 40 centimetres. So it'll be 40 times 40 for the area of that square. So it's 40 squared. And the height of that small pyramid is just this 48 centimetres. There we go. So that's the calculation that we must do to get the volume of the block. So let's bring in our trusted calculator and let's start working this out. So 1/3, that's 1 divided by 3, that's a third, times 90 squared, 90 raised to the power of 2, so that's 90 squared, times 108. That's fine. And we have to subtract. We can do this calculation all in a winner. 1/3 again, that's 1 divided by 3, times 40 squared again, there's the squared button, times 48 this time. And there's our final answer. So it's 266,000. Now, what's the measurements? Everything here is in centimetres. This is a volume, so it must be centimetres cubed, or cubic centimetres. Well, to calculate the volume of the block, we'll just leave it as that, cubic centimetres, 266,000. So here's question 10. We're presented with two algebraic fractions and we have to find the difference of them as a single fraction in its simplest form. And normally what we do when we're dealing with questions like this, suppose we had 7/10 minus 2/12. We could change both of these to 120ths by multiplying this by 12, and we'd have to multiply the top of the fraction by 12. Multiplying the bottom of this one by 10 gives you 120, and multiplying the top of this by 10. So we'd end up with 84 120ths minus 20 120ths. So how many 120ths have we got? We've got 64 of them. And there's a bit of cancelling going on there because 8 goes into both of these. So it's 8/15. So that is then simplified. There was a cancelling went on there. So it's a case of getting both the denominators as the same number. So in this case, x minus 3 in the denominator in the first one, x in the denominator of the second one. And we can get these the same by multiplying the two together to get the denominators in this form, x times x minus 3. So let's look at the first fraction and say, what have we done to x minus 3 to get into this form? Well, we've multiplied it by x, so that must happen on the top. X times 7, or 7x must appear there. And in this second fraction, what have we done to the denominator to get it into this form? We've multiplied it by x minus 3, so we must multiply the top of the fraction by x minus 3. So we've reached the stage where, in this case, we've had both of these as 120ths, and we can combine them and say, well, how many 120ths have we got? So in this case, how many of these have we got? Well, we take this number, 7x, and subtract this number, 2 lots of x minus 3. So that's where we got 64 from, 84 minus 20, 64 120ths. So let's try to simplify the top of this fraction. We'll have 7x, and then multiplying out both terms by this -2, we'll get -2x, and -2 times -3 is plus 6. So on the top of the fraction we've got 7x minus 2x, that's 5x plus 6. On the bottom of the fraction we've got x times x minus 3. Now, can we further cancel this to simplify it? Well, the only possibility would be a factor in common in the top. There's no common factor there. We just have 5x plus 6, so there's no further cancelling can be done. So that's the final answer to this question in simplified, in its simplest form. Well, here's question 11. It's about Anna's grandfather clock and the height of the tip of the hour hand, that's a small hand above the floor, given by this formula where x is the degrees that the hour hand has turned after 12 o'clock. And we're asked to calculate the first two values of x, for which the tip of that hour hand is exactly 150 centimetres above the floor. Well, let's have a closer look at her clock and let's watch it in action. So there's the hand, and there we can see the hour hand, that's the red one. And watch the tip of this. H is getting smaller and smaller. That's the closest it is to the floor, and now it's increasing and getting back up to where the value of H would be the greatest. Now let's concentrate on one particular height, like the question asks us. Suppose we go to 2 o'clock and consider that height. Well, there's another time where that hour hand is exactly the same height, and it's at 10 o'clock. There's it back to 12. So there's two places that hour hand is at the same height above the floor. So the question asks us about the height of 150 centimetres. We want the height of the tip of this hour hand to be exactly 150 centimetres above the floor. So we're looking at H being equal to 150. And we're given the formula for the height above the floor. It's 20 cos x degrees plus 157. So we want that to be 150. Now normally in equations like this, if you have something like 20a plus 147 equals 150, you would move all these things around to get a on its own, and you'd get an answer a equals. Well, we'll do that, but this time we'll get an answer for cos x. So our first move would be to take 147 away from both sides of the equation. So that's gone. 147 away from 150 is 3. Now we get rid of times 20. We divide both sides by 20. So that 20 disappears there. And we'll get 3 divided by 20. And we now want to find what x is. And we do a cos to the minus 1, or arc cos, or a cos, whatever your calculator is telling you for that. But before we do that, let's have a look at the cosine graph. Now, 3/20ths, you go 3 divided by 20 in your calculator, you get 0.15. So we're looking for angles that give the cosine value of 0.15. That's around there, a height on the graph above the x-axis of 0.15. Let's draw a line just to highlight where they might be. So there's a line, height 0.15 above the x-axis. Let's put that 0.15. So there's a point there, so there'll be an angle in the first quadrant between 0 and 90 whose cosine is 0.15. But you'll notice there's also one there. There's an angle somewhere in the fourth quadrant. That's between 270 and 360. That's the fourth quadrant. Remember, first quadrant's here, second between 90 and 180, and third quadrant between 180 and 270, and fourth quadrant between 270 and 360. And you can see from the graph that the cosine's positive in the first quadrant and the fourth quadrant. Some of you probably work from the cast diagram to do this. And you'll see that cosine's positive in the first quadrant, as is the sine and the tangent. They're all positive in the first quadrant, but the cosine's positive in the fourth quadrant also. And that, of course, ties up with what we've been seeing in the graph. Now, by symmetry, you can imagine a symmetry line down through 180. There's x equals 180. If we flip this over, there's an arrow showing us the angle that has a cosine of 0.15 in the first quadrant. If we flip this over, then the arrow would be pointing that way. Mirror image of this, and therefore to find the fourth quadrant angle would subtract that first quadrant angle from 360 to get the fourth quadrant angle. Now your calculator, when you do this cos to the minus 1, 3 over 20, will give you the first quadrant angle. Let's have a look at that. Now make sure your calculator's in degree mode, not grads, not rads, but in degrees. There should be a deg floating around or you'll get the wrong answers. So cos to the minus 1, 3/20. And in my calculator, that button there is the cos to the minus 1 button. It says what angle has a cosine of 3 divided by 20? And the answer is 81.37 degrees approximately. So we'll put that in here, 81.373 and so on. So we know that's the first quadrant angle, and the fourth quadrant angle value of x would be 360 minus 81.373. In this quadrant, you go all the way around to 360 and subtract the first quadrant angle. You can see that from the diagram there, from the cosine diagram. So let's calculate that. We do 360 and subtract that answer, and there we have it, 278.62 and so on. Calculate the first two values of x for which the tip of the hour hand is 150 centimetres above the floor. So the required values are x equals 81.4. I'll take them to one decimal place, so we'll keep the 0.3, chopping a 7 off, that'll move up to 4. So 81.4 and 278.6, chopping a 2 off, the 6 just stays as it is. So we'd better state how accurate these are. They are both to one decimal place. So here's question 12. We're presented with an algebraic fraction and asked to simplify it. Now suppose you were presented with 20 over 22 and you were asked to simplify that. Well, you just cancel 2 top and bottom to get 10 over 11. Now that's because you know there's a factor of 2 in 20 and you know there's a factor of 2 in 22. So you've now factorised both of these numbers and you've spotted a common factor top and bottom. So you would cancel that 2 into the top line, 2 into the bottom line, and you'd end up with 10 over 11. So you're basically cancelling the factor that's in common between the numerator and the denominator. So we'll do a similar type of strategy to try and simplify this fraction. And we'll try and factor the top and factor the bottom. Now, the top is a difference of 2 squares, x squared minus 4 squared. And the pattern is always x minus that times x plus that. If you're not sure of that, multiply out the first outsides, insides last. X times x is x squared. The outsides are 4x, the insides are negative 4x. They cancel. so there is no x term there. And the last, negative 4 times 4, does give you negative 16, or negative 4 squared. So that's our first move. We factorise the numerator. 2 factors. Just like we've reached this stage, we've factorised 20 into 2 factors. Now let's go to the bottom line, x squared plus x minus 20, and we'll assume that this quadratic expression can be factored. Firsts, outsides, insides, lasts. So the firsts, there's no choice, x times x. There is a choice for the last two, this times this. If we forget about positives and negatives, that will give us 20. We could have 4 times 5, 2 times 10, 1 times 20. 4 and 5 are a good choice because the outside 2 gives you 5x. Now remember, we're ignoring positives and negatives just now. The inside 2 gives you 4x. And these combine in this quadratic to give you 1x. How do we get 1x from these two? Well, we take a positive 5 and subtract 4x. In other words, the 5 is positive and the 4 is negative. Now, always check that things are working by doing your firsts, outsides, insides, lasts. So the firsts, x times x, gives you x squared, which we're after. Outside 2 is 5x, inside 2 is negative 4x, that gives you 1x. The lasts, negative 4 times positive 5, does give us negative 20. So again, we've reached this stage, 2 times 11, factored the 22. Now, what did we do? We looked at the top factorisation and the bottom factorisation and discovered there was a factor in common. Well, here there's a factor in common, x minus 4, and we can cancel these off. And that leaves us with x plus 4 on the top line, and no need of these brackets anymore, and x plus 5 on the bottom line. And that's our fraction simplified. Now it's interesting, if you put x, this is just a by the way, if you put x equal to 6 in this expression, 6 squared is 36, 36 minus 16 gives us this 20, 6 squared is 36 plus another 6 is 42, minus 20 gives us 22, and you'll notice 6 minus 4 is that 2, 6 plus 4 is that 10, 6 minus 4 is that 2, and 6 plus 5 is that 11. And at the end, 6 plus 4, 10, 6 plus 5, 11. So that example, that numerical example I gave you at the start, is one example of this. I mean, we could shove in x equals 7, x equals 8 and so on, and they would still all work. So there's your answer, x plus 4 over x plus 5 is the simplified form of this algebraic fraction. So here we have question 13, and we're asked to simplify 2 lots of sine squared x plus 2 lots of cos squared x. Now, a couple of things. First one, if we're given 2x plus 2y, for instance, what could we do with that? Well, we can take out a common factor of 2 outside the brackets. Well, there's no reason why we can't do that in this case. After all, sine squared x, cos squared x are just unknown numbers, just like x and y were. So let's take 2 outside the brackets. We'll take out a common factor of 2. And we're left with sine squared x plus cos squared x. Now that should ring a bell as one of the trig formulas that you've learnt. It's useful to remember the unit circle. That's a circle that has a radius of 1. And if we put a rotating radius in that circle, then the x and y coordinates of that point are the values of cos x and sine x. So the height of that point is always the sine, and the x coordinate is always the cosine. Now in a right angle triangle, this side squared plus this side squared will give you this side squared. And if it's a unit circle, it's got a radius of 1, then this hypotenuse must be 1. So that's a wee illustration of the formula that you should know by heart. If you don't learn it, you will not get this on your formula sheet, that the sine squared x plus cos squared x is always equal to 1. Well, there's a tough one. I think the answer's 2. So here's question 14. So we're presented with this storage unit in the shape of a cuboid, and we're given the various measurements of length, breadth and height. We're told the volume is 45 cubic meters, and we're asked to show that this is a valid equation, quadratic equation in x. So because it mentions volume, let's have a look at the volume of a cuboid formula, and it's length times breadth times height. And in this case, the length is x plus 7, the breadth is x, and the height is 2. Length, breadth, height. And we write that in a slightly different way. We usually put numbers at the front, 2 times x plus 7, and just leave out the multiplication sign. So it's 2x outside brackets with x plus 7 there. And we're told that volume is equal to 45. So 2x times x plus 7 will equal 45. And let's multiply out this bracket. So both terms get multiplied by the 2x. 2x times x is 2x squared. 2x times 7 is 14x. And that equals 45. So one last thing to do, if we look at this equation up here, we've got 0 on the right hand side. So we'll have to take away 45 from both sides. So 2x squared plus 14x minus 45 is equal to, and if I take 45 away, I'm left with 0, which is the quadratic equation that we were asked to find. So let's now have a look at the second part of the question. We're asked to calculate x, the breadth of the storage unit, giving our answer correct to 1 decimal place. In other words, we take this quadratic equation and solve it. Now the hint is that our answers have to be correct to 1 decimal place. That would imply this doesn't factorise and we use the quadratic formula. Now you are given the quadratic formula on your formula sheet. There it is. So let's proceed with this. So 2x squared plus 14x minus 45 equals 0. And let's compare ax squared plus bx plus c equals 0. That allows us to find out what we're plugging into this formula. So you compare the coefficient of x squareds. How many x squareds do I have? A is 2. How many x's do I have? 14 of them. And what's the constant c at the end? It's negative 45. So our values of x we'll find by plugging these into this quadratic formula. So we've got negative b, that'll be negative 14, plus or minus the square root of b squared, that's 14 squared, minus 4 times a times c, which is negative 45. And that whole calculation has to be divided by twice a. So that's 2 times 2. Well, let's keep going with this. There's negative 14. We can do a little bit of calculation here. Using your calculator, 14 squared is 196. Check that. And we're taking away, and this product has a negative in it, so when we're taking away a negative, that'll be adding, so this will become plus. And why have I got an a in there? That should be a 2. Looks healthier. So twice 45 is 90, 4 90s are 360. And we divide that by 4. So that allows us to work out what our calculation is. We'll just do one final step there, which is 56, 556, I think that's correct. You check that in your calculator, and we divide that by 4. So 2 values. We'll get x by taking negative 14 and adding the square root of 556 and dividing all of that by 4, or x will equal negative 14 minus the square root of 556 divided by 4. So there's the 2 alternatives. So we'll need a calculator to do all this. Here we go. So let's work out this first one. So negative 14, and we're going to add the square root of 556. Now, steady on. We've divided the whole of the top line by 4, not just this last piece. So we'll need to work out the whole of the top line first. And that's what we get, and that's what we've to divide by 4. And that gives us, let's write this down, 2.39 and so on. Or the alternative to that is negative 4. Oh, negative 14. Mistake there. So negative 14 minus, this time, square root of 556, and it's the whole of that divided by 4, so I'll better work that out first and divide that by 4. And here we go. It's negative 9.39 and so on. Now let's look up at the question, what the question is asking us. And we're asked to calculate x, which is the breadth of the storage unit. Now, the breadth of the storage unit can only be a positive value. So this is not a valid solution. So the only valid solution and we might maybe put in brackets positive, just to emphasize what we're doing here, is x equals, now they're asking it to 1 decimal place, so it's 2.4, chopping the 9 off, the 3 goes up to a 4, is 2.4 meters. So here's question 15, and we're dealing with a triangle ADE, of which we know the area 160. Now, the area of a triangle can be found in 2 different ways. If it's a right angle triangle, then we can use a half base times height. Triangle ADE is not a right angle triangle, and therefore we would have to use a trig formula to find the area of it. And the trig formula is this one, given to you in your formula sheet. The area is a half AB sine C. Now, that refers to a triangle ABC. So let's draw a triangle ABC. And remember the conventions that capital letters for the angles, the side opposites lowercase letters. Capital A, lowercase for the side. Capital C, lowercase c for the opposite side. And the area tells us it's a half of A times B. Now that's a couple of sides that meet at angle C, so it's a half the length of A times the length of B times the sine of the angle in between them. So for this formula to work, two sides are needed and the angle in between them. Now looking at this triangle ADE, let's have a look at that. This side AD we certainly can work out. It's 18 plus 6, which is 24 centimetres. The side AE is the one we're trying to find. And the angle in between these, we don't know. However, since it would be involving the sine of A, there's a right angle triangle where we can find out the sine of that angle, opposite over hypotenuse. So everything seems to be in order for using the area of this triangle being, in this case, little d. Well, it's a half of side little d times little e times the sine of the angle in between them, which is A. So we do know these, some of these things. Little d we're trying to find out. Little e is 24. And the sine of A, well, let's have a look at that triangle. The sine of A, opposite over hypotenuse, in a right angle triangle, remember, that's 8 over 18. So that's not a problem, we can work that out. So let's keep going with this. So the area, remember we're told the area is 160, so we can put that in. A half d times e, which is 24, times 8 over 18. So that's the calculation that we'll need to do. Now 8 over 18, 4 over 9. Cancel that 2 and this 24 to get 12. We can do even better. 3 goes into 9 3 times. 3 goes into 12 4 times. There's a bit of a mess now, so let's see what we've got. On the right hand side we've got d times 4 times 4. That's 16d on the top of the fraction. Underneath we've got a 3 left here, and that's it. So we've got 160 equals 16d over 3. Let's multiply both sides by 3. That's 480. You can check that in your calculator. And that 3 will go. And also let's divide both sides by 16, leaving you d on its own. So we've got 480 divided by 16. Well, do this in your calculator, but 16 goes into 48 3 times with that 0 would imply d is equal to 30. Now, what does the question ask us? It asks us to calculate the length of AE, which is lowercase d in this triangle. So we've discovered that. So the length AE is equal to 30 centimetres. Well, that's Mr. Corsi signing out, and hope you enjoyed the video.